Yeah, welcome to massive open online course on chemical process intensification. So, we are discussing under module 12, the topic is microprocess technology for process intensification, and under this module today we will discuss something more about that process intensification, and this will include the process intensification by microreactors and some barriers and its challenges. Now, we have already discussed that what is that microreactor. So, we will just look around that previous some introductory portions of that microreactor. We know that chemical synthesis and processing by application of a continuous flow microfluidics is known as chemical microprocess technology, and microfluidics is a science by which that fluid flow phenomena is manipulated and controlled usually in the range of that microliters to picoliters in network of channels with dimensions from tens to hundreds of micrometers. And also we discussed about that the reactor that used for these objectives are comparatively small and can be called as chip based reactors or simply called microreactors. And these microreactors having a microstructure zone that can be also referred to as the microstructure reactor. And the execution of the chemical process inside a small volume like microreactors, typically inside the channels with diameters of less than 1 millimeter. This is generally called as micro channel based reactor or other structure with sub millimeter dimensions. Also, we have discussed that chip based reactor is dealt with the operation of a large number of parallelized micro channels, and in that case how those microreactors are being used for chemical processes as a process intensification. So, process intensification by use of microreactors, we can have different applications of this microreactors where maybe gas liquid system, even some other multi-phase systems or liquid systems, even some reactive system. So, in that case several applications of these microreactors based on the process intensifications are actually being carried out and also that is commercialized based on that performance of the reactions and separation process based on this micro reactor and also micro process technology. Now, in that case, if we consider that gas liquid microreactors and can be applied like that as an example toluene and various other fluorination reactions and also to carbon dioxide absorptions, and this type of reactions generally happen in a channel where that you can enhance the mass transfer and yields of the reactions there. And reactions may be that amenable to process intensification when performed via high temperature, high pressure and high concentration routes, and also when using aggressive reactants. The microreactor is only used when it is really needed, and of course, you have to consider the cost factor for changing the processing, and also you have to keep it as minimum as possible. Now, if we consider that the high pressure and high temperature microreactor processing that we have discussed in our previous lecture, that several that aspects of implementation of process intensification by this microreactor processing, they are of course the pressure and temperature are two important factors by which you can have that process intensification in the microreactor systems. In this case that if you increase the temperature maybe it will increase the reaction rates by order of magnitude as per reported by Hessel 2007. However, the impact of the increasing pressure is more manifold, maybe based on that several aspects. Maybe it may be applied simply to avoid boiling under high temperature conditions, and also for increasing mass transfer for gas liquid reactions, and also it may be that impacted for that changing the reaction mechanism through solubility effects, or you can say that through supercritical states, and also using the that steric effects like that volume of transition state, and also it may guide the products and isomer selectivity based on this that high pressure and high temperature microreactor processing. So, these are the some impact of increasing pressure on this reacting system in the micro reactor. As an example, if we consider that for drastically increasing temperature like Kolbe-Schmidt reaction of resorcinol to 2,4-dihydroxybenzoic acid. In that case, that if you use that pressurized capillary heated system by an oil bath and a micro heat exchanger for the temperature quenching, in that case you can get that increase of yield for these reactions, and if you do it for certain condition of this pressure and temperature, you may get that intensification of this process. Now, experimental condition of in this case microreactor processing for this type of reaction, in that case pressure may be of 40 to 70 bar, a temperature of 100 to 220 degrees centigrade, and a reaction times of 4 to 390 seconds. However, a recommended reaction time is to be 2 hours at pressure of 1 bar and at 100 degrees centigrade. So, anyway directions is going to that process intensification based on the microreactor processing. Several even research also is to be carried out to how to get that these reactions based on low pressure as well as optimum temperature there. So, this is one example where you can increase the temperature and get that a reaction performance in the microchannel based reactor. And in this case 2,4-dihydroxybenzoic acid is produced via conversion of resorcinol with aqueous potassium carbonate solution at 100 degrees centigrade and applying a carbon dioxide pressure of 4.5 bar. And also this is formed the byproduct which is formed is favored at high temperature and long residence times. So, in that case due to the continuous processing and its small dimensions, the experimental setup offers the capability to improve the selectivity. So, that is why here that process intensification at this high pressure and temperature, which we can get the improvement of the selectivity by this microprocess technology. So, in this case Hassel et al. 2007 reported that using the high temperature micro reactor processing method, the Kolbe-Schmidt synthesis can be completed with less than 1 minute at comparable yields to batch operation as shown in figure here, and in that case a reduction of that reaction, hence reaction of the reaction time hence by a factor of 450 around at comparable yields can be achieved as they concluded. And also this may account for the reactor volume as well. This corresponds to an increase in space time that yield by a factor 440, that is reported by Hassel again in 2008. Now, this this picture is generally giving that yield with respect to temperature for a various flow rate for the aqueous Kolbe-Schmidt reaction of resorcinols to 2,4-dihydroxy benzoic acid using pressurized capillary demonstrating feasibility of reaction times of some that 10 seconds there. So, this is the intensification where we can get by this micro channel based reactor for the better that selectivity of these reactions in the micro channel. And the high temperature processing principally enhances the side and consecutive reactions most remarkably at long residence times. And a similar process intensification by pressurized high temperature operation was obtained for the Michael addition with several alpha beta unsaturated amines and esters by that Benito Lopez in 2007, even by Hessel et al. In 2008 there. So, they have reported that this process intensification by the pressurized high temperature operation can be obtained for the Michael addition with several alpha beta unsaturated amines. So, this is the direction of that process intensification for that reaction at high pressure and high temperature. Also, Hessel 2008 reported that this faster kinetics led to the increase of the heat released, which demanded efficient heat removal and also the avoidance of thermal overshooting. In that case, the yields that may be ranging from 95 to 100% and at reaction times of few seconds to some 10 minutes. That may be dependent on the substrate, and also you can say that that operation of high pressure and high temperature can be established based on this microchannel based reactors, and also high productivity that can be achieved giving a space time yield increased by a factor of about 650 in the best case as per Hessel et al. 2008 they have reported. Some other applications like sequential combinatorial synthesis of pyrozoles. In that case, sequential slug flow operation was reported to prepare a combinatorial library of pyrozoles which offers in general a wide range of biological activities. So, this is also one important because whenever fluid will be flowing through the micro channels maximum mostly the flow pattern is slug flow. So, they have done here I think Garrica, Egido et al. 2003 they have reported that this slug flow pattern also give that that process intensification for this synthesis of the pyrozoles that is carried out by means of a NOR reaction as given in the slides here. So, this is also possible based on that flow pattern of the fluid during that reaction and also how that kinetics of the reactions are changing based on that flow pattern through the channel. So, it is one of the important example of this synthesis of pyrozoles based on that flow pattern and how that intensification is possible for this reaction system. Another example, it is called the direct fluorination of aromatics and aliphatic reactants. In that case, these are also very important reactions that are actually being carried out in the microchannel based reactor, and in this case this direct fluorination of the aromatics and aliphatic reactants, there are several still disadvantages of carrying out these reactions in the microchannel based reactor even in conventional systems also. But still since research is going on, there are several aspects is now going to consider how to actually intensify the process and how it can be carried out in the microchannel and by the microprocess technology. In that case, the insufficient control over the heat release makes it difficult to comply with safety regulations as well as to control the chemical selectivity. So, research is going to overcome those disadvantages of these reactions to be carried out in micro channel or conventional system. But microstructure reactors that may allow to overcome both problems and in this way provide an alternative route to the existing multi-step processes like the base a seabed reaction and also helix process as typical industrial pathways for the generating fluoroaromatics there. So, microstructure is giving some extent of the solution for this problem over this conventional technology, but still research is to be carried out for better and better understanding as well as that improvement of the process performance by this microstructure reactor. Photo oxidation of dienes by singlet oxygen also are being carried out in microreactor system. In this case, a photo oxidation is the cyclo addition of terpene that is carried out in the single channel chip reactor by that is investigated by Uthun et al. 2002, and they have reported that by this procedure the process safety can be increased because the reactant that does not need to be pre-saturated with the singlet oxygen. So, this is also another one of the important application of channel based micro reactor like SIP reactor there. Also, these micro reactor systems are also important for the application of fine chemicals and functional chemical production. In this case, if we consider the synthesis of phenyl boronic acid, the main difficulty of this reaction is the control of selectivity and the high reaction rate that sometimes demands a fast mixing of the reactants and adequate heat control to prevent side reactions. So, to actually take the advantage of the micro reactor technology to overcome this fast mixing of the reactants and adequate heat control to prevent these side reactions are actually demanding, and also they are suggesting to actually research communities, they are suggesting to do these reactions for this fine chemical and functional chemical production in the channel based reactors. And also since the mixing is one of the important issue there, so that should be used in a micro mixer based reactors there. So, to cope this demands, the contacting of the trimethyl borate and Grignard reagent generally was realized with various micro mixers as per report of SL 2002. Now, there are other synthesis like azopigment synthesis there. With regard to blocking the synthesis of azopigments possesses high demands on microreactors, and microreactors offer the chance to achieve smaller and more uniform particles to improve the color properties, and also here to save dye during the printing there. So, azopigments are very useful chemicals for that printing purpose. So, to synthesize these azopigments in the micro reactors are also one of the important aspects of the process intensification there. And these pigments are shipped with the laboratory scale reactor showed a sometimes larger color strength of 119% and 139% respectively compared with the same products that is made by base processing. So, how we see that how micro reactor systems are giving better performance as per process intensification, and as per report of this that Wiley et al. 2002 that they observed that these pigments in the laboratory scale reactor showed a larger color strength of 19% and 139% respectively for that compared with that some same products made by that base processing there. And also the monochlorination of the acetic acid also one of the important reactions that is carried out in micro reactor there. for getting that yield even more and more compared to that traditional synthesis. In this case, this yield up to 95%, which was slightly higher than the yield of traditional synthesis, that is reported by OL et al. 2000s. And it was also reported that this monochlorination of the acetic acid in microstructure reactor led to a much higher selectivities, and therefore, rendered further purification steps unnecessary there. And in this case, the amount of the unwanted dichlorinated products that is coming out was less than 0.05%, while in the conventional processing that may result that more than 3% there. And the number of applications that is using the advantages of this chemical microprocess technology, we can say it is still growing, because there are several issues which is to be overcome for getting more better way of that product, even green product, and also you can say that more intensified way. So, among those are more and more applications which focus on industrially relevant processes to be considered there. But there are some barriers, and of course, that challenges to be executed for these several reactions when you are considering that to be intensified in the economic way and even greenery way. So, the green synthesis that or green sustainable way of development that is required for this process intensification, just by considering all those shortcomings what is coming during that process intensification in the microreactor. So, that should be that considered for the further research, and also those are very important aspects that are actually given some barriers and challenges here, like that we will discuss that some barriers of that in later. Let us see that other applications of the microreactors for like absorption reaction, chemical absorption processes for gas separation applications that can be substantially enhanced using the microreactors that utilize microstructured surfaces, channels, and fluid feed systems. And if we consider that absorption of carbon dioxide that uses aqueous dimethylamine, even other amine solvent also you can use in the microreactors in microchannel based microreactor, and that is also one of the important aspect of the process intensification for the separation of the gases. Like other application here, extraction process also can be done, liquid extraction in the microchannel based microreactor. There you will see that some application of that separation process based on that intensification in extraction, it is given in the slides. I think there are several aspects. There extraction of copper using some solvent, extraction of zinc using solvent, even uranium extraction by the ionic liquids, even separation of platinum using amine. So, those are different aspects of application where you can do it in a micro channel, even chip reactor microreactor, sometimes membrane microreactors, sometimes it may be chip type reactors, sometimes it will be that T junction based microchips reactor, micro mixer settler, even the that Y type microchips based microreactors, microfluidic chips. So, all those different types of microreactors that can be used for that extraction processes, even here given some examples of those extraction process. So, please go through this this application of this extraction which can be done in the micro channel for the process intensification. Even you can apply this micro reactors in evaporation process. In that case, the combination of the falling film channel based microreactor should be developed with a carrier gaseous system, and it is generally made out of aluminum magnesium alloys for getting that safe and stable evaporation of hydrogen peroxide with vapor or liquid equilibrium that almost reached at the top of the evaporator. And also the falling film microreactor that utilizes the ability of a liquid stream to wet a surface and also governed by the gravity forces spread to form an extended thin film. That is reported by Claim et al. 2011. You can apply crystallization also in that micro channel based reactor. As per Jiang et al., you will see that in 2014 they have reported that the formation of L-asparagine monohydrate crystals in deionized water by channel based microreactor, it can be done. And in that case, including crystallization in a continuous slurry undergoing laminar flow in a tube by cooling through its walls, that will be very prone to clogging for some solute solvent. So, that should be taken care. Sometimes whenever crystals will be formed in the channels, that may clog that other flow. So, that is why nowadays that thinking about that crystallization process where that nanocrystals can be formed in that microchannel in a process intensification way. Now, what we discussed that there are of course, in the different applications like absorption, crystallization, extraction, even some other different reaction systems, that whenever we are applying that this micro reactor for this application to be carried out, there will be some barriers and also some challenges which is to be solved also. So, there are several researches going on how to recover, how to overcome all those these problems or barriers there. Some barriers like here micro reaction technology today, implementation problem. So, the successful implementation of microstructure production process in industry, that depends on the process analytical technology, because you have to analyze anyway whatever products is coming out. Maybe online analysis of that micro channel based reactor, it is very difficult. So, whenever you are going to carry out that reactions in a micro channel, how that kinetics of that reaction and also how that concentration of that reactant systems are changing and conversion are changing, that should be analyzed by that analytical sophisticated analytical system, and which is still under down because of that several pros and cons in development. So, still research is going on there. So, anyway, the successful implementation of the microstructure production process in industry, of course, to be depending on that process analytical technology. And also time and spatiality resolved online analysis must be implemented directly in the microfluidic channels, and parallel and multiplexed measurement technologies are also needed to reduce cost and increase the robustness of the information for this micro technology. Now, more information about the actual reaction process, that is inside the microreactor and microchannel, is also required by that sophisticated micro analysis. And characterization of chemical reactions in a fast and reliable way, even on a molecular level, is also a challenge job. Also, in many cases you will see that novel microprocess technology solutions for existing production processes have to compete with already depreciated plants. This significantly affects the overall economic scenario. And also a suitable technology is still to develop to analyze that accurately several microchannels simultaneously, or to analyze a single microchannel spatiality that is resolved along the that reaction path. The multi-scale concept referring to the interaction of microreactors with conventional plant technology is an issue which is still not actually fully resolved, as per a statement of that Hessel et al. 2004. And microreactors have completely different heat and mass transfer characteristics than conventional starred base equipment. So, in that case you have to follow some existing protocols to be changed to more harsh conditions there. And for this reason, expert simulation tools sometimes to be needed to predict that potential benefits of that chemical microprocessing technology for that heat and mass transfer characteristics analysis in the micro reactor. And also novel processes can rely on the direct synthesis from the elements under harsh conditions, and the direct fluorination from elemental fluorine and the hydrogen peroxide synthesis from a detonating oxygen or hydrogen gas mixture is one of the important examples where we can get that barriers to get this intensified way of that yield of the reaction. Novel processes can achieve the elimination of additives, catalyst and other auxiliary the agents, since processing in a microreactor that is changed. Also you can say some challenges involving reactor design, engineered catalyst especially designed for the microchannel reactors, method of fabrication results in technological insights and also innovations that spurred future development, and also initial catalyst investigations in 1996 that revealed that direct wash coating of microchannels was presented significant hurdles to rapid developments there. Many of the significant breakthroughs in microchannel reactor design resulted from the developing designs for specific commercial applications. So, challenge is there that you have to design that microchannel based reactors in such a way that there will be that some complex microchannel system to be easily designed based on different thin metals, based on different other economic aspects, even how to overcome that corrosions, even other aspects of that reactor systems where that chemicals whatever it will be used, reactants it will be used, that may that reacting with that surface of the reactors in the microchannel. So, that should be also considered during that design. So, that is why the design aspects of the microchannel which is to be rigorously taken care of those breakthrough points where it can be that considered for the design for that of microchannel based reactors to get more intensified way. So, there are several other issues also in microchannel based reactor design. There and also concepts whatever it is there may be in terms of mass transfer characteristics, heat transfer characteristics, even some other reaction kinetic systems also to be considered, and also residence time of the reactants and also for the physical processes, how that micro reactors can be used for separating that or creating that that interfacial area to get more yield of that reactive separations, or you can say that absorption system separation, physical separation, all those things. So, microchannel based micro reactors are nowadays that important aspects for the process intensification in chemical engineering. So, I think we have discussed lot about that application of that microchannel based reactors, and there are some barriers and challenges. I think it is useful for your that better understanding of that microchannel based reactor here. Also, whatever reactions or separation processes are there in the microchannel, all those separations or reaction kinetics that depends on that hydrodynamics of that microchannel based micro reactors. So, it is also to be known what are the different hydrodynamics characteristics of these microchannel based reactors, that is to be also to be known, and how those hydrodynamics may affect on that mass transfer and heat transfer for the reaction systems in the microchannel based. So, we will discuss more about these microchannel based reactors for their how that hydrodynamics and other characteristics, even mixing characteristics is also one of the important aspects that also to be discussed in the coming lecture. So, I will suggest you to go further for the application of this chemical microprocess engineering and processing, and also how they are using this reactor systems in industrial systems. I will suggest you to go through these references for more information about this. So, thank you for this.